Alright, 17.4 is pretty fun. It's talking about symmetry. Symmetry I think is pretty visual, so I don't think this is a hard section. And so the essential question is, how do you determine if a figure has line or rotational symmetry? And these are the two types of symmetry we deal with. And you're definitely going to have to know how to define these. So 4 words, right? 4 important words. Line symmetry, rotational symmetry, lines of symmetry, and angles of rotational symmetry. Okay, so line symmetry is just if a reflection maps it onto itself. So maps the figure onto itself. So let's look at an example of this. So line symmetry. If we have an isosceles triangle right here, an isosceles triangle, this does have line symmetry because there is a line of symmetry right here, which means that if you were to reflect it across that line, you would get the exact same shape, right? So it has a line of symmetry right there. All right, for instance, one that does not have lines of symmetry would be a triangle like this. That one looks pretty even, actually. Trying to make it a little more off. A little more non-isosceles. So something that's a scalene triangle. There's no line that you could cut right here, or that you could put right here, where if you reflected it across the line, you'd end up with the exact same triangle. So this one does not have line symmetry. This one does have line symmetry. Okay, rotational symmetry. If a rotation maps the figure onto itself. So for example, a star. Let's just assume my star is perfect because I'm a super great artist. Oh, this is such a bad star. I have to try again. Wow, this is terrible. Okay. Alright, that's better. Okay, so rotational symmetry. So can I turn it and make it look like a star again? Well, yeah, I can turn it a couple different times to make it look like a star again. I could turn it 1, 2, 3, 4, 5 different times and it's still going to look like a star. Okay, so my angle of rotation is how much do I really have to turn it to make it look like a star? So 360 degrees would be if I had to turn it all the way over, all the way back around. But we can do that 1, 2, 3, 4, 5 different times. So really our angle of rotation in this case is 72 degrees. And what that means is that all of these are 72 degrees. And we just have to flip it or rotate it 72 degrees to make it look like a star again with the point up, right? And it would look the exact same. Right, so we're going to look at a bunch of different shapes and identify, does it have line symmetry? Does it have rotational symmetry? And how many lines of symmetry? What is the angle of rotational symmetry? 42, yeah, good. Okay, erasing this. Alright, here we go. So, first shape. Assume that this is a perfect rectangle. Alright? And we've got a perfect L. Okay, so we want to identify, do these have line symmetry? Do these have rotational symmetry? Line or rotation? So this shape right here, if we folded it, if we put a line right here and reflected it across that line, assuming it's a perfect rectangle, it would have line symmetry there. if we folded it in half here, right, if we reflected it over that line, that is line symmetry. But we can't put a diagonal line. You can try it. You can try it, but when you fold it, these corners are not going to match up. It's not going to look like the exact same shape. So this has two line symmetries. Okay, 1, 2. And now let's look at rotation. So if we rotated this, let's try 90 degrees. If we rotated it 90 degrees, it would look like this. That didn't work. We don't want it to look like that. If we rotated it 180 degrees, it would look like this again, though. That's exactly what we want. Okay, 270 would look like this. It's not what we want. Not what we want. So our angle of rotation is 180 degrees. So 180 degree angle rotation. So it does have line symmetry and it does have rotational symmetry at those two measurements right there. This one over here, if we try to do line symmetry, right, we're assuming that this is the same length. This length is the same as this length, okay? Which it doesn't really look exactly like it does. Let's make it a little better. That looks a little better. Okay, so line symmetry. I can't cut it there. I can't cut it here. I can't cut it here. But if I cut right there, if I folded it along that line, my two sides of my L are actually going to line up. If I reflected it over that line, it would make the exact same shape. So this has one line symmetry. Okay? And let's think about the angles of rotation. The typical ones we're going to look at are when it's like a boxy shape is 90 degrees, 180, 270. If I rotated this 90 degrees, it would look like that. It doesn't look the same. If I were to rotate this 180, it would look like that. And if I were to rotate it 270, no, not like that. There we go. Like that. Perfect. None of these look like the one above. So this has no rotational symmetry. There is none. There is no way to turn this and make it look like the exact same L unless you go all the way around to 360 degrees. And that one doesn't count because that works for every shape. Okay, let's do two or three more. We'll do two more, then I'm going to put 4 up for you to do. Assuming that this is a square. Okay. And we are also going to do Alright, so we're looking at line symmetries and rotational symmetries. So this one right here, cut it in half, or you could actually cut it in diagonal halves because we know the sides are the same length. So what that means is that it does have line symmetry. In fact, it has 4 line symmetries. Okay. Rotational symmetry, a square, 90 degrees, 180. Right, if you turn it, there's 4 different times that you could turn it where it looks the same. So that's 360 degrees divided by 4, which means that every 90 degree turn, you have rotational symmetry. So there's a 90 degree angle of rotation. This next one is arrows, line symmetry. Okay, well we could cut it in half right there. Fold it in half, it's going to look the same, or reflect it across that line. Okay. Can't do any diagonals or anything like that. But we could also cut it like this. So this one has two line symmetries. And for rotational symmetry, you flip it all the way around, right? So if we look at 90 degrees, it's going to look like that. That does not look the same. 180 degrees, though, is going to look like that, which does look the exact same. 270, you're going to be back to the sideways. Okay, and then 360. So right here, this does have rotational symmetry, has a 180 degree. Right, so you could turn it here or here. 180 degree angle of rotation. So when I give you some to do on the left-hand side, the two things that I need to know are how many line symmetries, what is the angle of rotation, right? And assume that even though my drawings are absolutely horrendous, that they are perfect. So first one. Okay. Second one. Second one, that is a kite. Third one. Fourth one. Alright, so you're telling me line symmetry and rotational symmetry for these four on the left-hand side.